Okay, our next speaker is Keith Wiles. Keith is a software architect from Intel. He's a long history in networking. He'll be well known amongst the DPDK community as the author of PacketGen, and he's also a key contributor to the OPNFV data plane acceleration group. So he's going to talk about future extensions to the DPDK framework.
Well, I'm the guy standing between you and lunch. They always do that to me. So, find my slides. Figured. Where are they all at, Tim? Well, I'm going to try to talk to you about some of the, this is Windows. I don't mess with Windows anymore. So I was going to try to talk to you about what we're going to do for DPDK AE, which is DPDK acceleration enhancements. We're trying to discuss what it is we want to do and why we want to do it and how can we get there. Okay. Well, you guys seen this slide. It's probably in some cases it's just a kind of a history of what's going on with DPDK and what we're trying to solve and partly where we're trying to go to as well. So it's really just trying to discuss why DPDK is here, some of the pieces that we're trying to add, how long it's been here. It's been here for 5+ years now, so we're doing pretty good. We need to extend it and keep moving forward, and that's kind of what we're going to go through here next. So this is another, I like pictures, words sometimes are difficult to put on slides and make any sense out of them. But this one is more of an overview of what DPDK is today. We have a lot of pieces in DPDK. It's a lot of features and software. We also have a lot of Arch ports out there. Some are private, some are not. And we're trying to at least promote that direction for us, is to get more Arch ports and add more software and more hardware support for different drivers and so forth. So what we're going to talk about here is DPDK AE, and the AE stands for Acceleration Enhancements. It's just kind of our term to try to where we're going to put, what we're going to add to it, how we're going to make it work. A couple of things we do see, or at least I see, is we need to add more acceleration support. Right now we have Ethernet devices, we have some crypto devices and some other pieces of software. But what we really want to do is add more crypto, more hardware device support. Hopefully next week we'll be able to show you some other crypto APIs that we're trying to propose. A DPI engine, you name it, we want to add those pieces in there, encryption or compression. There's also the match action flow classification software that's out today, and we'll talk about that in a minute. We need to also add support for SoC hardware, which are non-PCIe based devices. We need to support those, and we need to come up with a resolution or a solution to make those work. One of the other things we want to do is also enhance VirtIO. I missed one. VirtIO is a key piece here, and VirtIO is pretty much everywhere, and we need to figure out how to enhance that performance. We've heard a few people talk about VirtIO's performance, adding multi-queues and so forth. Hopefully that'll get done here soon, and we'll get a better performance from VirtIO. We also want to add network stacks and lightweight threading and other pieces of applications that sit on top of DPDK to give more application-derived features instead of just low-level packet I/O or compression or crypto. But those are the goals. And one of the other things I want to discuss about is supporting other language bindings. And we'll get into those. You may or may not be interested, but I am, I guess. And we've actually heard some people here. So here's a crypto API that we're going to try to propose here soon. And what it's really trying to do today is create an environment where we can have multiple pieces of hardware and or multiple pieces of software in the same environment for crypto. So one of the things is packets, especially for crypto. Large packets are great for crypto hardware. They can do it much faster than we can do it in software typically. But small packets, they have an overhead for setup and pass into hardware. And a lot of times software can do a better performance job of doing crypto and software. So we want to meld those two together and make it seamless to the customer. So some of the advantages is we get a better range of packet size performance. We get some parallelism out of the software and hardware at the same time. And this also means that we can get parallelism, hopefully, out of the hardware as well, in some cases. So the big goal is to make that completely transparent to the customer or the application that uses it. If you have any questions, please yell at me. Now this is, you can barely see it on these slides, unfortunately, but Jim just gave you the presentations. This is the crypto API we're hoping to promote to the industry as a RFC or as a patch set to give you a better crypto API that's generic to hardware and or software. So this is a goal today. We have ETHDev. We're creating something similar to CryptoDev in DPDK that is a crypto set of APIs that are generic. They don't adhere to any particular piece of hardware or software. So this is an example, and I'm not going to go through it, but it's an example of how you do configuration. As you can tell, it's relatively simple, although it's very difficult to see from this perspective. And it does similar things what you'd expect from the standard implementations that we have today. So we'll go off to session management. And this is setting up and tearing down sessions. And that's typical in crypto today. Sure.
One question about the slide before. It's still forward, so I'm not sure if it's. Do you have plans to support both symmetric and asymmetric crypto API?
Yeah, that's one of the goals we're trying to get to, and it's right now. It is something that needs to be done. So we're looking to try to support that in the future. It's not currently in that implementation, I don't believe, correct? No, it's currently not in there right now. But we are trying to get there. I think it's a valid place to put it, and it's definitely something we need. So this is how the sessions are teared down and built up. Unless you have specific questions, I hope. Sure, go ahead.
So there are AAD algorithms like ASGCM that you get the hash as a side effect of running crypto.
Right.
And how do you fit that into this separate crypto and hash API?
Right now, we aren't necessarily covering that piece, but it's something we need to add. Right now, we're pretty much taking the only piece of hardware we have for crypto, which is our Coleto Creek or Cave Creek hardware.
Supports PCM.
Yep. And we're using our QAT software that we've been running that was kind of a bolt on to the side, and now we're trying to bring it underneath DPDK as a real entity and try not to make it a different set of APIs and a different set of code and so forth. Yes?
One piece of feedback on the QAT, you have to have that carbuncle on the side of your face called the config file. You can do anything so that when I'm on a usually I can find out capabilities and there's different number of engines and there's so much in that config file that you have to set up, it gets pretty difficult.
Yeah, and that's one of the things we want to try to avoid. Right now we do have the configuration side here that does have some structures to help define what it is. I'm not the best person to ask the question on the crypto side, but I believe we're trying to solve that problem to get rid of that. One of the things is trying to bring QAT into DPDK as a first-class citizen instead of this bolt-on, and that's what you run into is these configuration files that sit on the side. We want to make it so that it's much more transparent and much more easy to configure from a DPDK perspective.
So that config file is not required, it's just how the tools work.
Correct. I think whenever we get the submit out the patches, hopefully that'll answer some of your questions on that. I don't know when we're going to be able to do that yet.
As soon as 2.1 is done.
Yeah, as soon as 2.1 goes out, so that'd be great. Anytime.
Maybe today, maybe tomorrow.
It'll fall out of the sky, so we'll see what happens. This one is some of the operations and how to set up some of the hashes and so forth. I'm not going to try to spend too much time on that. This is the packet processing side, how you queue a burst. It's very similar to the same API you see for an ETHDEV. This is primarily for look-aside, but we're trying to make sure that we don't hinder an offloaded IPsec implementation as well. Okay, so next we're going to go into flow classification. And right now we use, sure, go ahead.
Excuse me, but is there a way you could turn up your mic volume a little bit or change the mic placement?
Actually, even if you just go
Sometimes
to
they're hard to hear.
look, anytime you turn your head to your left, you stop using the mic.
Oh, is that what it is? Try to get it closer together. So, sorry about that. I'll try to stand and turn my body. How's that? Yes?
I'm not sure if it's too early to ask. Are you going to provide, supporting data like ECUs if you're going with a smaller packet size, doing the software is better?
Well, the goal we want is to allow you as the developer or the application select whether you want to do software or hardware or both. There will be some configuration options to help you choose as to whether or not you're going to do software and hardware. It's not quite currently in there yet, so the goal is to give you that option. So you may not see it reflected in this RFC yet, but that's the direction we're trying to go. Okay, so one of the things we're going to try to do is flow classification. And one of the things that we just open sourced is the match action API set that we use for some of our current hardware. And one of the things that we do in DPDK today for flow classification is we use flow director API. Flow director typically is tied to a particular piece of hardware, but it is also never failed. You get a call in the middle of the thing. So the flow API is with the flow director, and it's contained currently in hardware in some of the Nantec devices and so forth. But what we want to do is utilize that same API to provide that to anything, any type of hardware. What we want to do is bring under our match action API, which is open source, you can see, and utilize that. It's basically a superset of what you can do in Flow API or Flow Director today. And there'll be some hardware that can take advantage of more features than what Flow Director can do today. And we want to be able to continue and support that as we go forward. So we can support any number of devices out there. So in this particular case, we're trying to make it backward compatible. So if we bring this piece in, you shouldn't see any difference in your Flow Director code, because it'll either go from the device type to the actual physical PMD to be programmed into hardware, or it'll go to some other device based upon our configurations in DPDK. I've really kind of covered this piece already, as trying to talk about how we deal with the Flow Director API. What we're trying to do is match action, because it is a superset. We want to also extend Flow Director's API, or in some way extend it to encompass more of the match action APIs, and also include hardware support or other devices that come into this play. So really what we're trying to do is just enable more and more devices, either software, hardware, whatever you want to do. So the next piece we want to do is a look at SoC support. SoCs do a lot of things, and they have a lot of functionality built into them, but we don't support them today. They're typically non-PCIe based configuration, so we need to figure out how to support that. Now this is my vision as to where the SoCs need to fit into this environment. Even though they support crypto, compression, flow director, whatever else they need to support, we need to handle all of those pieces at one time. And what we're looking at here is adding specific SoC PMDs that do either crypto or compression or whatever else. There may be multiples of those in that platform. And just create a PMD level API, just like we've done today, and that's our abstraction to the hardware itself, like we have always done. And then we further add other device types, which is our application abstraction to the hardware to control those devices, whether it's software or hardware. In this case, it's mostly hardware. But some things could be done in the SDK that's typically accompanied with an SoC. Is there any questions on this particular slide? Because I typically get a bunch of questions on this one.
For an SoC?
Say that again?
Can you give an example for an SoC? What,
A Cavium, Broadcom, you name it, whatever's out there. It's just, well, if you look at it from my perspective, it's an integrated piece of hardware that does a lot of things, not just packet I/O. It may do compression. It may do other things as well. That's what I'm saying. And typically these are embedded onto the board of those platforms. They don't have a bus associated, like PCIe associated with them. So that's what I'm calling an SoC, some sort of system on a chip that does a lot of functionality that we need to take advantage of. Right now, all our devices pretty much sit on a PCIe bus. Now, that doesn't mean that these SoCs can't sit on a PCIe bus as well, but they typically don't in some cases, or in some platforms. Because remember, we're trying to go to other architectures as well, and those other architectures may or may not have PCIe. They may have some other bus type or memory map devices and stuff like that. So what we're trying to do is figure out a place to put those pieces. And this is, I think, a good place to put it right at the moment. All this stuff in the green is something we're trying to add. And it doesn't mean that we need to add it. I'm talking about DPDK community needs to add. Yeah, Bill.
So a quick question. In this model, does this permit SoCs to execute applications or simply to accelerate applications that are executed elsewhere?
Execute applications?
Yeah. I mean, it runs the VNF, for instance.
In this particular case, these are accelerated devices in this environment. So they're utilized by the VNF or the application. Not necessarily the VNF is going to control the device directly. Because we're trying to abstract it so we can allow for any number of devices or any devices out there.
SoCs typically have execution cores run computations, not just
Sure. At this point, we're just talking about the acceleration pieces that are in those SoCs. If they have offload cores doing work, they're probably being utilized in a dual architecture environment anyway. So they still have to conform with some sort of API between those two core, between the host core, if you want to call it that, and the execution cores that are on that SoC, right? So from that perspective, I see that it may be yet another API that we need to add here. Maybe there is another set of APIs that we need to add to be able to allow to push applications down to these execution cores that run on these SoCs, which is not shown here. But there's things like that need to be added, and we just need to do it. So in this particular case, since I'm better talking to the right side today, the SoC over here is just an exploded view. Kind of give you an idea of where I think and why we're putting it there. Trying to maintain the same level of abstraction that we do it in all kernels today. There's typically a device layer, and then there's typically a driver layer of some type that does the translation to hardware. And that's all we're looking at. This allows us to get to different devices within the system, and it also should support pretty much everyone out there. It should give us the same level of performance that we see today, depending upon what is done at the SoC layer. Some of the SoCs have SDKs that have different models of memory, different models of packet formats, things like that, and we need to address that. We're not trying to talk directly to hardware. We need to go through the SoC's SDKs. Now, these devices are non-PCI devices, and that's one of the pieces we need to fix. They also have their own memory management system and their own hardware event-based systems and everything else. We need to support that models as well into the system. And we also, in general, need to support an event-based model on DPDK. Now, some people have done that in the industry, but it's not something you can pick up from dpdk.org today. So here are the pieces I think we need to do somewhat immediately. We need to add configuration options so we can configure these non-PCI devices. They're typically some sort of memory address or something like that. We need to support external memory managers other than what we currently have today, because those memory managers is just basically mempools and everything else. We need to figure out a way to allow these pieces of hardware that are controlling memory and freeing of packets and so forth, how do they get their job done as well without having to take it away from them? Because that's where all their performance is. And their memory may be also memory mapped someplace within the system. We need to be able to map into that. It's also not just for SoCs, the external memory management. It's also for other entities that have, let's say, a stack that has a completely different memory management scheme, and they want to still retain it. So this is also a software-based external memory management, not necessarily hardware as well. So one of the other things we need to do is support event-based model programming and also events. Today we don't do that directly. There are applications like Open Event Machine and things like that that sit on top of DPDK that give them an event model for programming, but we don't provide one. So do we want to adopt Open Event as that model or pick something else? Or maybe there's multiples. There's also, as Bill points out, another reason for us to also investigate what these SoCs really need from our perspective. Any questions? So now I'm going to talk about network stacks. And I bet you everybody in here has their own favorite one. Say that again. Well, remember DPDK, and what we're trying to promote here is DPDK is a multi-architecture platform. And it may run on an example, a MIPS platform that has SoCs associated with it. And we want to take advantage of that. That's what I mean. Other than just a pure Intel piece of hardware, which has PCI devices and so forth. So we need to support those as we go forward. And that's one way to try to get everybody working on the same page with DPDK.
FPGA support also fits into the SoC?
Yes, definitely. FPGAs also fit into that same realm. Anything that fits into that category.
How do you see the relationship between DPDK and because what you present is basically what Open Data Plane would like to achieve somehow.
Yeah, and Bill will shoot me. He's from Lenaro, so anyway. I see the Open Data Plane currently as an opportunity for us to they've unified a lot of the SoCs underneath that umbrella, but I see it sitting at that PMD layer, not at a higher layer. So that's something we discussed in the DPAC, the Data Plane Acceleration in OPNFV group. So if you want to get into that one and argue the points there, but you're right in some cases, but there are some advantages to both. And there are some advantages, I think, to DPDK because it supports n number of devices at the same time, and it supports a lot of different other features. And that's where I'm trying to put these pieces at. And I'm not trying to debate ODP versus DPDK today. That's for another talk, I think. But we can go to that. You can talk to me after this during lunch if you want. So network stacks. We need network stacks. The question is how many of them? Because everybody has their favorite to do various different things. And I think, from my perspective, we need multiple stacks. And we need an interface to DPDK to place these stacks on top of so they can be interchanged easily. And we don't have that necessarily today. Everybody probably has their own interface, underlying interface to DPDK through a network stack, but not necessarily from a perspective of somebody else's network stack being able to swap in and swap out. So we need to look at that and understand it. We can't get one stack because somebody wants low latency, someone wants high throughput, someone wants just UDP, someone wants SCTP, somebody wants whatever. So our goal is to figure out how we can make that happen. Now we have some examples here, UDP, TCP, just an IPv6 stack, SCTP. How do we support those pieces and maintain a reasonable set of stacks? I don't want to have 4,000 stacks, but maybe 3 or 4 might be reasonable. But when we do that, we have to maintain and figure out how to support that. There are some different problems with stacks. There's an upper layer and a bottom layer of stacks. And if you've ever tried to do it, you'll figure it out. Just the bottom layer seems to be pretty simple to do in some respects. It's the top layer, the application layer. How do you interface to the application? Is the application another process? Is it in the same process as DPDK? What is your goals there? Is it using sockets? Is it not using sockets? So really the question is what does it need to be supported? And there's a bunch out there.
You plan to have all these network stacks modular. I mean, like TCP/IP, you can split it into the IP stack, IPv6 stack, and TCP stack, so that you can combine them in every combination.
There's been some discussions of people wanting to do that within the company, and I think that's reasonable, but I also think that it won't solve everybody's problems, because once you add the interfaces, sometimes those interfaces can cause you problems. But I think it's something we need to look at. It's not necessarily, if somebody comes up with a very modular stack that can be interchanged and swapped out and has high performance and low latency and everything else, then that probably would be the adopted model. But there might be other people that say, oh, well, lightweight IP is the greatest thing since sliced bread, stick it on top of DPDK, and that's all I need. And that may be true. Yeah. But I guess I'm not really talking about what's inside the stack, per se, as far as modularity or how it works. I'm talking about how do we get it on the DPDK and use it from a community perspective, and then support it from a community's perspective. So, as we heard from Sarah, is that they do an LD preload for sockets. That's a pretty reasonable thing to do. We want to accelerate native applications as well as other applications. They may not benefit from the best performance, but at least they don't have to change those applications, and that's a big thing. Stacks, if you have DPDK, you may have multiple instances of DPDK running. You may have multiple cores with individual stacks running. Do they look like one big stack from the outside world? They look like 14 small stacks or stacks, and how do you integrate those? So those are different use cases for different models. There's also whether or not you integrate that stack with the host stack. What does the host stack see? Does it even care? Is it just for management, or is it really there for other things, right? So you have to at least understand how you're going to integrate network stacks and the host stack with all these other stacks, or this stack, if you want to call it that. And it's a tough problem. Some people have solved it. Typically, netlink messages are one area. You monitor and manipulate all the netlink messages, and then update the accelerated side versus the host side. So you have to be able to accelerate the traffic, and you have to still support in-management traffic as well. And that's typically the slow path, if you want to call it that, from the accelerated to the non-accelerated side. is that you still want to manage your data within the accelerated network side versus an external management side. You could have an external management side as well, so we need to support that piece. So one of the things is everybody either loves or hates FreeBSD. I kind of like FreeBSD. At least it's up to date. It has a lot of protocols. It's not necessarily built in this environment, for this environment, but it is definitely a network stack that runs and is up to date. That's one of the bigger things that we saw in my previous life at Wind River is that everybody wants an up-to-date stack. Some people don't, some people do. So it was difficult to give them anything else than an updated stack and something they could actually work on. If you gave them some foreign code that typically did an excellent job, they may or may not like it, depending upon whether they understand it or not, but that's okay. So FreeBSD gives us this capability. Can we take FreeBSD and make it into a network stack? Turn it into a piece of code we can download and very skillfully integrate it in DPDK without changing it, and so that we can take updates from FreeBSD automatically, almost, with maybe a very simple patch. We can do that with other stacks, and the reason why I'm pushing on FreeBSD is it's non-GPL'd. So other people may have other ideas of different stacks. There's others out there. MTCP and so forth is one of them. So one of the things we were talking about is just trying to see if we can pull down FreeBSD, apply light patch, be able to build it within DPDK quickly and easily, and at least provide you with a networking stack with a set of protocols and/or in file systems for that matter. You could actually get very creative as to everything that's inside DPDK or inside FreeBSD and figure out how to maintain it. Yeah.
Is FreeBSD stack currently 0 copy?
I'm sorry? FreeBSD stack is not, from the socket perspective, 0 copy.
The upper end, no.
Now, if you had if you're willing to modify the application, you can probably get 0 copy in there, but nobody's standardized on a 0 copy API. It'd be nice for us to do it, I think. I'm sorry?
The batch processing part, so this is something that DPDK gains a lot.
Right.
Do we have any idea of making a general purpose stack using batch processing?
That's actually some of the things we've discussed. I haven't seen one directly yet, but in reality, a lot of stacks would benefit from that batch processing or that burst mode capability. Most of them just send a packet down at a time. So there's probably an opportunity for us to enhance the FreeBSD stack to do that batch processing for DPDK. We just have to push those pieces back into the upstream community for FreeBSD. And I think they would take it. They really want the best performance. Huh?
I guarantee they'll take it.
Yeah.
I mean, with money, I would guarantee.
Yeah, so enhancing FreeBSD.
The other thing you're going to run into is there's sort of a two-pass router like that in FreeBSD
Yeah.
right now. But it's Keenan and I are all, but it's
Oh, okay. Yeah, with George. Yeah. I know George. He used to work with me in Wind River way back when. So it's a very small world. With that, we'd like to make that direction, and we want to make sure that we include and upload or enhance FreeBSD. I think that's a good path. Whether that's what everybody wants is another problem, or another issue, and somebody might want something else that's more attuned to what they really want. So we'll do it that way. VirtIO we just talked about a little bit. VirtIO is really kind of the default out of a VM. We really need to make that performant. We can do SROV out of a VM, but that also limits you in migration and various other issues associated with it. SROV typically has a limited number of virtual function interfaces that you can attach to. So VirtIO is probably your better bet. Now SROV works really well in a host environment if you have DPDK or OVS and so forth. So that might still be maintained. But VirtIO is probably your primary path out of a VM today. and we need to improve that performance. And we have some things going in the works, I think, and some other people as well. I'm almost done. You guys getting hungry yet? So one of the things I want to talk about is language bindings. And in package-in, I attached it to Lua. Somebody else mentioned Lua here today as well. So that you can do some configuration and support and so forth with a scripting language. It's much easier than compiling and generating and all this other stuff. So it makes a good sense to at least do some language bindings. Now there's two different classifications of language bindings. There is scripting language bindings like Lua and Python and so forth. And then there's others which are more compile time options like Go or Swift or something like that nature. So those are very popular. So do we need those? I think they come into play. Lua can be a very good configuration and setup scripting language tool for you. There's some applications out there today like MoonGen that does traffic generation with Lua, and it's all done through Lua, unlike package-in primarily is done through the screen interface. So we have these language bindings. Do people really see them useful? I see them as useful. I don't know if anybody else sees them as useful in a deployment world. So you can trade off performance and ease of development. So the other thing that gives us in this is Lua is a scripting language, but it's not object-oriented. Python is object-oriented. Go and Swift or something else, they are object-oriented languages, and they give you some advantages over the top of your applications. Do they provide all the performance you need? Maybe, maybe not, depending upon which version you go to. What we really want to do is make DPDK or libraries within DPDK do all the real grunt work, but leave the applications to do setup and configuration and whatever else you want to do in that language. SnapSwitch? Oh, yes. Yeah, they're all written in Lua as well. Yep. Yeah, MoonGen does the compiled side. Does SnapSwitch do compiled Lua as well? Yeah. That's one of the advantages is these compiled scripting language. You can get some pretty decent performance as long as you pay attention to where the performance needs to be, where the delineation line shows up to be. So to kind of summarize, we need to add more accelerated hardware support, and we need to add it in a clean way to DPDK. And we need to come up with the goals for what that means. And this way we can have anyone contribute devices and or software to this environment. The goal for our acceleration is to try to provide a software and or hardware implementations because in some cases, as I stated before, it's advantageous to have both at the same time. We need to contribute other ports to this platform so that we can get a little bit wider perspective and understand what their needs are, because we don't do it today easily. A bunch of companies do have them, but they don't contribute them back. So we'll see if we can figure out how to get that done. We need to add the SoC enhancements just so that we can cover some of the bases that everybody needs for these devices and for non-SoC devices for that matter. Like an event programming language is not necessarily surrounded by an SoC. I think the network stacks are one of the biggest places we need to add, because a lot of applications need a network stack. They can't rely on the host. They can't write their own. We need to figure out how to accelerate those. We need to figure out how to accelerate things like Nginx that we don't want to rewrite or change. How do we accelerate it, at least something? Maybe it's not 10x, but maybe it's 3x or whatever the number turns out to be. And of course the language bindings. I think that'll help us in the long run. Java has its own place in the world. Pick your favorite language binding. How do we enhance those language bindings for everybody to use? And really the big thing is we just need to collaborate, figure out where all these pieces fit, and how do we combine them together. It's really easy to understand why we need these pieces, but putting them in, we need to collaborate and figure out how to do that. So that's really it. So, 2 minutes to go. Any other questions?
On the language bindings, have you thought at all about how to deal with runtime? So, for example, if we're trying actively now to test the application in Java, but we've had to basically initially compile out any usage of the DPDK for the most part to run it because, like, how do you initialize the environment instruction layer from the Java VM without those two interacting with each other?
Yeah, that is definitely hard.
I was asking how you deal with the runtime of JVM and the EAL.
Yeah, really, it's how do you configure DPDK, which is its own entity, has its own command line interfaces, its own configurations from the Java VM at the same time. And those are difficult to do, and a lot of people just ignore it and say, we'll write a configuration file or we'll write something else to do that configuration. We need to figure out a way to better support that. Some people don't like, passing command line argument type things to DPDK. They'd rather have a structure type mentality or something they can change on the fly. So we need to understand that better. So there's definitely a place there for that. Yes? It's actually a superset of flow classifications. So it does a lot more than flow director. And it was developed for a different piece of hardware, but they've made it generalized so they can open source it. And what we're going to try to do is at least support the flow director because we want to maintain backward compatibility instead of trying to bring in something completely new. Right. Yeah. Exactly. I agree with you 100%. True. I agree with you 100%. And it's kind of like this environment configuration. We provide command lines that are pretty much static, but we don't provide interfaces to possibly change them sometimes. And in some cases, they can't be changed, like deleting a mempool or something like that. Yeah, exactly. Yeah, and I think that's what we need to look at. You're absolutely right. But I think we're a big enough community we can do all of them at once. But we do definitely need to focus on the stability if we have any stability problems, and also these other pieces that are out there. It's like any piece of software that grows, multiple people contribute. Okay, is that it? All right, go to lunch. Oh, hang on. What? Is there one question? I'll talk to you. Come by and talk to me.
Okay, we're going to break for lunch, and if we could be back about 1 o'clock, we'll be back on schedule. Thanks, guys.